Here is a very interesting question for you. It's again time, position and velocity graph. Okay. Create a time position graph for Ruth. She starts 320 meters from her house and walk towards her house at 2 meters per second for 2 minutes. Explain the choice of your scale, right? So in this graph, we're trying to make distance and time graph, correct? So time is independent variable, so we will take it along the horizontal axis. So that becomes time t. Now, since the units are meters per second, seconds is the time unit, right? So we'll write time in seconds. Now that is our choice. Now vertical axis here is the distance, and let's say this is d, and the units for distance is meters. So this is origin at O. Now starting distance for us is 320 meters, which should be somewhere along the vertical axis. And then we are given that Ruth walks towards her house at 2 meters per second for 2 minutes. So it's a good idea to find out. After all, 2 meters per second for 2 minutes means how much distance will Ruth cover in that duration, right? So if the speed is 2 meters per second and time is 2 minutes, then the distance should be, let's look into our triangle, right? So let me make our speed distance triangle, right? So, and then we'll calculate. That is distance, speed and time, correct? Now we are given that speed is 2 meters per second. So we know speed is 2 meters per second. And time is 2 minutes, right? 2 minutes. Let me write minutes first. And now since we are working in seconds, we'll convert the units to seconds. So there are 60 seconds in 1 minute. So it'll be 2 times 60, right? That gives us 120 seconds, right? So the time which we need to consider is at least 120 seconds, right? So that is the time. During this time of 120 seconds, how much distance will Ruth cover? That is another thing which we should look into. So distance is equals to speed into time. Now here speed is 2 meters per second, so 2 meters per second into time, which is 120 seconds. 120 seconds, right? Seconds and seconds cancel. 2 times 120 gives us 240 meters, right? So basically, in 2 minutes, Ruth is going to cover 240 meters, right? And since she starts at 320 from her house and walks towards means distance is going to decrease, right? So after 2 minutes, what is going to be the distance? She started at 320, right? So that is the starting 320 minus 240, correct? Let me do minus 240, because she will cover 240 meters during those 2 minutes, and that gives us 80, correct, meters, right? So during this time, 80 meters of distance will be covered, right? Now let's select a scale. So along the time axis, we should have at least 120 seconds, correct? Because we have to cover the distance for 2 minutes, right? Now how many units do we have? 1, 2, 3, 4, 5, 6, 7. So if we go by 20 seconds, it's a good idea, right? So if I 20, 40, 60, 80, 100, 120. Do you see that? So by 20, it is a good idea. So we should choose a scale so that our basic unit is 20 seconds, right? So if it is 20 seconds, 20, 40, let me write 40 first, right? 40, 60, 80, 100, 120. And this becomes 140 and 160 seconds, right? So that is how we are going to select the scale for the time. I hope you appreciate it, right? So We were interested to show 2 minutes on our time scale, and we counted the number of units we have, and accordingly we selected, right? So 120 divided by, let's say 6, gives us 20 each, right? If you go by tens, you can't really show 120 here, right? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. It goes beyond the scale. Do you see that? So it's very important to select the right kind of scale. So we have selected a scale where each unit is 20 seconds for us, right? Now on the vertical axis, we need to show 320. Now 320 and then a distance of 240, which covers 80 meters. We have a common factor here, which is 40, correct? So it is a good idea to use 40. So 40, 80. Let me write 80 here. 120. So I keep on adding 40s, right? So 80 times 160, correct? And then 200, 240. 240 and 40, 280. And then we have 320. Correct? So that is a good scale to choose, right? Now, since we have a good scale here, see how clearly we have marked our distance. Second, there is no approximation, right? If you go by 40s, we get a multiple, 320, correct? 8 times. So 8 units. 1, 2, 3, 4, 5, 6, 7, 8. Correct? So that is how we choose a scale. So avoiding inaccuracies, correct? If you choose a scale by 50s, then it will be 300 and 350. 320 will be a somewhere in between, leads to approximation. So that will not be a good idea. 40 is a much better unit to take in this particular example, okay? Now, let's make our graph, right? Now we have to create time position graph for Ruth. So we have this time, distance, and let's look into the positions. She starts 320 meters from her house, so that is the starting point. D-intercept, right? So that is the starting point, d-intercept. That is the first position. You understand why we say position? Position includes both time and distance. This is where Ruth starts. 320 meters away. At t equals to 0, she is 320 meters away. And after 120 seconds, that is this, distance covered is 240, right? And if 240 is covered from here, we are 80 away. So at time 120, we are 80 away. So we are here. So this is our final position, right? So that is the final position. And to draw a graph, we will join these two lines, right? These 2 points with a straight line. Why a straight line? Straight line for 2 minutes. Then we specify that she walks only for 2 minutes, and in 2 minutes she covers a distance of 240, correct? So each is 40. 240 means 6 units, right? 1, 2, 3, 4, 5, 6, correct? So that is distance of 240, and the remaining distance is 80 meters. So at the end, Ruth is 80 meters away from her house, right? So that is how we are going to sketch this graph. I hope you understand and appreciate how we selected the scale and how we sketch the time position graph for Ruth. Thank you.